record. So what does this question want you to find? We know they want you to find the area in the finite region, right? Well, the area of the finite region. What information did they give you? Well, they told you that the gradient function, okay, this is giving us a lot of trouble, so bear with me, okay? Bear with me, bear with. dy and dx is defined by minus 2x. Okay, that's giving me a lot of trouble. Let me close this and see if it works. Plus plus 1. Anyways, right. So they gave you the gradient function minus 2x plus 1. They also told you the point, let me just name it P, has the coordinates 2, 4. And they said that this point here lies on the curve, which has this gradient function. But they're not really interested in this, right? What they asked you to find is the area of the region. And they told you it's bounded by the two lines, x is equal to 0 and x is equal to 3. Yeah, I think it's x is equal to 3. There's a problem, right? Because for those who are with me, you know when finding area, we use this formula. Right, yeah. So you know when we find an area, we always use this formula, right? I said integration, differentiation. This whole section of your syllabus, which is introductory calculus, it's all about following the rules, right? Once you know the rules, you're good to go. You know from what we did in the previous session, when finding area of a finite region, you always follow this formula. A is equal to the integral of f of x. So f of x is the equation of the curve, right? F of x dx. dx just means with respect to x. This is definite integration, so you know you must have your limit. B is the upper limit. Hold on. People are joining. So, right. This is definite integration, so you have your limit. B is the upper limit, A is the lower limit. So you know every time they ask you to find area of a region, you always refer to this formula here. F of x is the equation of the curve. B is the upper limit, A is the lower limit. Where do you get these two limits? Just look at the x values, right? Whichever one is the higher number, that's the upper limit. The lower number is the lower limit. But there's a problem here, right? Because in the previous questions, they actually gave us the equation of the curve, which is f of x. So all you have to do is substitute it into your formula right here, find the area. In this case, they did not give us the equation of the curve. We need to find the equation of the curve. But how exactly are you going to do that? Well, when we were doing indefinite integration, we went through that, right? We said that that integration, the definition of integration, it's an anti-differentiation process, right? So what does that mean? In simple terms, integration is the reverse of differentiation. So when we were doing indefinite integration and the application, we actually learned how to find the equation of the curve given the gradient function. What we did was we had to integrate this gradient function. It's the same thing you're doing, right? So that's why it's important to you not only to understand my chat. For the people who weren't here with me, please let me know. Is that minus 15? I have no minus 15 here, so I don't know. This is minus 2x plus 1. This is a 2 or 4. This is 0, and this is 3. I don't have minus 15. Anyway. Okay. So, right. If you were with me before, or if you already did this in school or somewhere else, you know to find the equation of a curve when given the gradient function, what we need to do is integrate this gradient function. Why? Right? Okay. So we need to integrate the gradient function. That's how we're going to find the equation of the curve. So let's do that. We integrate in this. The expression here is 2x plus 1, right? So y is equal to the integral of the gradient function. to the integral of minus 2x plus 1, and then, hold on, people are joining, and then this is with respect to x, so you put your dx, right? Like I said, we did all this already. When we were doing application of indefinite integration, we did this. So this is nothing new, right?
Afternoon.
Afternoon. So, well, evening. Anyways, so, right, we integrated this expression, minus 2x plus 1. Can anybody tell me, so this is nothing new, right? We did this already. Can you tell me what would be the integral of minus 2x plus 1? Can anybody tell me what's the integral of this expression? We did this already. Like, it's the same thing we're practicing. Just apply the rule. Apply the rule. That's all you're doing. Y is equal to what? What's the integral of this? Anybody? No, the integral of minus 2x plus 1 is in minus x. So let me just write this again because I cleared it up by mistake. So we're doing finding the integral of minus 2x plus 1. That is how you find the equation of a curve when given the gradient function, right? We did this when we were doing application of indefinite integration. When you differentiate this expression right here, like I said, this topic, differentiation, integration, let me differentiate now. We integrating. But the topics, differentiation, integration, is all about following the rules. You just need to follow the rules and you're good to go. If I ask you to differentiate, integrate, my bad. If I ask you to integrate any expression, all you need to do is follow the rules. And we know the basic rule of integration is if you're given an expression in this form, ax to the n, then the integral of this expression is going to be ax to the n plus 1 all over n plus 1, right? When we are doing, and this is indefinite integration. How do I know it's indefinite integration? Because I don't have any upper or lower limit, right? So I always have to put the plus c because this is indefinite integration. Like I said, this is nothing new, right? We did this before. So all I'm doing, applying this rule to integrate this expression. That's all I'm doing, right? So looking at the first term, remember when you have sums and differences, all you need to do is integrate each individual term, right? Like I said, none of this is new. We did this already. We practiced it. We did all the past paper questions. It's just to apply it now, right? Don't forget what you learned before. You need to, you know, remember, right? So integrating minus 2x, following this rule. My a, which is minus 2, is going to remain minus 2, right? X to the n plus 1. In this case, it's understood that n, which is my power, is 1, right? So that's x to the 1 plus 1. Then this is divided by n plus 1, so 1 plus 1. Then I integrate the next term, which is 1. We know from the laws of indices where whenever I see a constant, it's understood that it's x to the 0. Because anything raised to the power of 0 is 1, right? So this constant, 1 right here, can also be represented as 1 by x to the power of 0. So applying my rule here, a is 1. I don't have to write the 1, but it means x to the n plus 1. N, in this case, which is my power, is going to be 0. So that's 0 plus 1. Then I divide by n plus 1, which is 0 plus 1 in this case, right? So 0 plus 1. And because this is indefinite integration, how do I know it's indefinite integration? Because I don't have any limits. This is indefinite integration, so don't forget to put your arbitrary constant plus c. And we went through why we needed to do that, right? This is nothing new. So simplifying this some more because we obviously can't leave it like that, right? So minus 2x.
Negative to the 2 over 2
Mhm.
and 1x 1 x
What's the denominator?
1.
1 plus c. But we could simplify this even more. I can reduce this right here.
Yeah,
Cancel
x
these.
squared,
Okay.
negative x squared
Here's an x
plus
plus plus. What's the next term?
x
X plus c. So y is equal to minus x squared plus x plus c. Everybody following that so far? This is nothing new, right? We did this before.
Yes, miss.
Okay, minus. Okay. But of course, you can't leave it like this, right? Why? Remember when you're doing coordinate geometry and you had y is equal to mx plus c, and if they ask you for the equation of the straight line, you needed to find the value of c. You couldn't just leave it as y is equal to mx plus c. So for the new people, what I mean is when you were doing coordinate geometry, right? So you had to find the equation of the straight line or whatever. Let's say your gradient m. So we know gradient is denoted by m, right? Let's say m was 3, and they asked you to find the equation of the line. You wouldn't leave your answer as y is equal to 3x plus c. You always find the value of c. Same thing here. You can't leave the equation of the curve as y is equal to minus x squared plus x plus c. I need to find the value of c. But how exactly do I do that? Well, just like you did with coordinate geometry, whenever you needed to find the value of c, what you did was take a point that was lying on the line, substitute it into here, and find the value of c. Same thing you're doing here. They gave you a point that lies on the curve, so all you need to do, substitute those values into your equation to find the value of c. Just like you did with coordinate geometry, right? It's nothing new. So can I erase this top part here? Or can I erase the whole thing? Like, is it okay if I erase the whole thing?
Yes, miss.
Yeah. No? Going on. Going fine. So wait, hold on. I can't. Somebody's joining. Give me a sec. Okay, I'm clearing. Okay. Right. What question is this? This was number 4. It was number 4 on the PowerPoint. Okay. So right. This is the equation that we're working with right now. Y is equal to minus x squared plus x plus c. But we said to find the equation of a curve, we can't just leave it like this. We need to find out what's the value of c. And just like you did with coordinate geometry, where you use the given point, substitute those values into the equation to find the value of c, same thing you're doing here, right? So they told you that the point 2, 4, that's the 2, right? Just give me some trouble. So 2, 4 lies on this curve. Whatever this curve looks like, there's a point that lies on the curve, and that point has the coordinates 2, 4. So now that I know a point that lies on the curve, I can use these values, substitute it into my equation to get the value of c. So what values am I substituting? Well, you should know that all coordinates of the form x, well, on the Cartesian plane, right? X, y. So the 4 is my y value, and the 2 is my x value. Using these two values, I'm going to substitute it into here to find my value of c. So y, we said is 4, according to this point right here, is equal to minus x squared. X is 2, so that's minus 2 squared plus x. X is 2 plus c. I'm trying to find the value of c. So all you need to do, make c the subject to find the value. So let's simplify this some more. 4 is equal to 2 squared is 4. So that's minus 4 plus 2 plus c. So please note, this isn't minus 2 squared. It's minus 2 squared. So let me write that down, because I remember someone asking me that before. So this right here is not minus 2. Oh my. Let's just, yeah. This is not minus 2 all squared. It's this. If it was this, then I would get my value to be 4. That's not what we're looking at, right? We are looking at minus 2 squared. So let me just put the squared in the bracket here. 2 squared is 4, so that's minus 4. There's a difference, right? Minus 2 all squared is not the same as saying minus 2 squared. Okay? In this case, we're talking about minus 2 squared, which will give me the minus 4. Just to clear that up, right? Because I remember somebody was asking me that. Okay, we simplify this. This is 4. Minus 4 plus 2 is going to give me minus 2 plus c. I add 2 to both sides. So therefore c, the value of c is going to be equal to 6. Therefore, my equation of the curve, which was, hold on my chart, which was the whole point of me doing this in the first place. Good evening, Kitania. So, which was the whole point of me doing this in the first place, was to find my equation. Y is equal to minus x squared plus x. But instead of putting c, I know the value of c is 6. So I'll put plus 6. This is my equation of the curve. Everybody understand that so far?
Yes, Miss, I understand.
Yes, Miss.
Okay, this is nothing new, right? This is not what they asked us to do. If they asked us to find the equation of the curve, then this would have been our answer and we can move on with life. That is not what they asked for. They asked me for the area. The only reason we did this, like find the equation of the curve, is because we need it in order to find the area. So can I clear this off?
Yes, miss.
Okay. So the only reason I did that is because I need the equation of the curve in order to find the area of the region. So recall the formula. A is equal to the integral of f of x, where a and b are my limits, right? So f of x dx. They already told us the limit. X is equal to 0 and x is equal to 3. I said b, which is the upper limit, is always the bigger number. So in this case, it's 3. A is always the lower limit. A is the lower number. So A is equal to 0 in this case, right? Hold on. All right, sorry about that. Okay, this is the formula we're using. F of x, it's always the equation of the curve. So we know the upper limit, b is 3, a is 0, and we now know the equation of the curve f of x, which is y is equal to, so just in case you didn't know, y is the same as f of x, right? So y is equal to f of x, and this is equal to minus x squared plus x plus 6. So now we have everything we need. We have the equation, f of x, we have our limits, b and a. So all we need to do, apply our rules, find the area. Don't forget your units. Let's do that. So looking at my equation, I'm just substituting the appropriate value. So this is equal to the, so a is equal to the integral of f of x. F of x is this expression right here. So minus x squared plus x plus 6 dx. In some trouble. Sorry. B, upper limit, which is 3, because 3 is the bigger number. 0 is the lower number, well, the small number. So A is 0. All you need to do, use the rules of definite integration. We did that, we practiced that, we did all the past papers with that. So all you're doing now, applying your knowledge of definite integration to find the value of the area. We know when we're using definite integration, the first thing you want to do, so just forgetting these limits for a little while, the first thing you want to do is integrate this expression right here. How do I go about integrating that expression? Use the rule. It's all about the rules, right? All about the rules. How do I integrate a given expression? It's called the integrand, right? Just in case you didn't. So if I'm asked to integrate an expression, I always follow my rules. The integral of an expression in the form ax to the n is equal to ax to the n plus 1 all on n plus 1. This is definite integration. How do I know it's definite integration? Because I have limits, right? Integration again. Yeah. So this is definite integration. How do I know that? Because I see limits. I have an upper limit and I have a lower limit. So what does that mean? There's no arbitrary constant. So you see what we did in the first case where I had the plus c next to this? We're not including the plus c here. And in the previous class, I showed you why we don't do that, right? So for definite integration, remember, you do not include that arbitrary constant. We do not put plus c. We just applying this rule. So looking at this expression, I'm going to use this rule, apply it to find my integral. That's all I'm doing. Just following the rule. Just follow the rule. And we know from when we practiced before, when you have sums and differences, so you see a minus sign and a plus sign, that doesn't affect anything, right? All you're going to do, see this rule here, you apply it for each term. So you use this rule to find the integral of this term right here, minus x squared. You use the rule to find the integral of x, and you use the rule to find the integral of 6. That's all you're doing, finding the integral of each individual term. We practiced that already. So if I give you minus x squared, and I apply this rule to find the integral, can anybody tell me what the integral would be of minus x squared? Just apply this rule. Anybody? What's the integral of minus x squared? Hold on, chat. Minus x cubed on 3. Or if you want to, you could write it as minus the third x cubed, right? Same thing. If I do x, I would end up with x squared on 2. And then if I do the 6, I'm going to end up with 6x. No plus c. Why? Because this is definite integration. Definite integration, no arbitrary constant. No arbitrary constant, no plus c. We're not putting the plus c. We did this already. So I integrated my expression, and then you know, when you're dealing with definite integration, then you put the little bracket there, you put your upper limit, you put your lower limit. From here, all I'm going to do, substitute this upper limit into my expression, substitute the lower limit into my expression, subtract those two values, and get my answer. This is what we were practicing before, right? Really nothing new. So just erasing this top part. So this is what we've been doing the whole time, right? It's really nothing new. So the first value, hold on. y6, okay. Let me use a different color. So 6 is a constant. Well, let me say constant. Let me not say constant. Let me say it's a pure number, right? 6. Laws of indices. My laws of indices, well, yeah. Laws of indices, there's a rule that says x to the 0, anything to the power of 0, so in this case my base is x, is going to give me 1, right? Therefore, instead of just saying 6 alone, it's implied that the base here and the power is x to the 0. Because it doesn't affect anything, right? X to the 0 is 1. So 6 is the same as saying 6 by x to the power of 0. And if I apply this rule here now, so my basic rule of integration, it says I need to add 1 to the power and then divide by this new power, right? So a is 6, x to the power of n plus 1, n is 0, and then the plus 1. All of this is going to be divided by n plus 1, which is 0 plus 1. I simplify this some more. 0 plus 1 is 1. So 6x to the power of 1. 0 plus 1 is 1. So this is going to give me 6x. Remember, you might be wondering where the power of 1 went. Well, there's another law that says anything raised to the power of 1 is itself. So by saying x to the power of 1 is the same as saying just x. You understand how I got the thing now? Wait. You understand how I got 6x?
Yes, miss.
Right.
Yes, miss.
Okay. So let me continue what I was doing. Erasing this, erasing this, erasing. So this is how you apply definite integration, right? That's what we are doing. Well, the people who were with me, that's what we were doing in the previous classes, right? That's what we practiced. So all you're doing now, in order to find the value of the area, you substitute your upper limit into the expression. So wherever you see x, you're going to replace it with 3. Then you do the same for the lower limit, subtract the 2 values. So if I take 3 and I substitute it into this expression, wherever I see x, I'm going to replace it with 3, right? That's what I'm doing. So I'll put it in a bracket, my first bracket. Minus, I see an x here, but instead of putting x, I'm going to replace it with 3. So that's minus 3 cubed. Let me just put a bracket here. Minus 3 cubed on 3 plus x squared, but instead of putting x, I'm going to put the 3. So that's 3 squared divided by 2 plus 6x. But instead of putting the x, I'm going to replace it with 3. That's my first bracket. You always subtract. Then I'm going to substitute my lower limit into here. So wherever I see x, I'm now going to replace it with 0. So what would this give me? Minus 0 cubed on 3 plus x squared. So this would become 0 squared on 2. Then 6x is going to become 6 by 0. All you're doing now, you're simplifying to get the value in each bracket. So you simplify this, get this value, simplify this, get this value, then subtract the both values, right? So this right here, just looking at it, I know it's going to end up being 0. So let me just put minus 0 one time. This is what we need to figure out now. What's the value of this bracket? Can you simplify it and tell me what value you get?
101, negative 1/3.
Anybody else got negative 1/3? Anybody else got negative a third? Okay, I have somebody else saying they got minus a third. Okay, let me simplify this. So minus 27 on 3. What am I doing? That's minus 1.